you must have attempted that. So no worries, we'll discuss that in the next class. Okay? Because I used to follow that always in my class, that first of all, we used to discuss the homework questions, and then we used to start with the rest of the topics. Okay, so is this clear to everyone?
Yes, sir.
Okay, so just if you are unable to do any of those questions, because there will be some. Okay, there will be some which you will not be able to do. So just mark it as your doubt, and then we'll see it in our next class. Okay, is this clear to all of you?
Yes, sir.
Yes, sir.
Okay, so let's start a fresh topic of today's. Okay, so let's have a little recap about our last class. Uh, so what were we discussing? First of all, again starting with the very old story. What is the x coordinate of the center of mass? Yes, Rasha.
M1 x1 plus M2 x2 so
Plus
on
so on, and whole
by
divided by
M1.
m1 plus m2 plus so on till as this will keep on going. Okay, and what is if it's a continuous body, then what is the formula for x coordinate of the center of mass?
L/2
Integration of,
x dm by integration of dm.
yes, x dm integration of dm. Okay, Zonara, tell me, if there is we need to find out the y coordinate of center of mass, then what will be the coordinate for that? Yes, Zonara, is my voice audible to you? Okay, Athia, tell me, what is the y coordinate of the center of mass?
Integral of ydm by integral dm.
Integration of y dm by whole dm. Okay, these formulas are for the continuous distribution of the mass, and these are for the point masses. Okay, and if we talk about the point mass, then it will be m1y1 plus m2y2 and so on till whole divided by m1 plus m2 plus so on. Okay, so these are the formulas that you must remember about. Okay, Aditya, tell me that what is the velocity of the center of mass? If the individual particles are having the velocity v1, v2, and so on, then what is the velocity of center of mass? How it is being defined?
m1 v1 plus m2 v2 by m1 plus m2.
Yes, and so on. It will keep on going. Whole divided by m1 plus m2 and so on. Okay, is this clear to you people?
Yes, sir.
We had seen one more thing here. That is for the acceleration one. What was the acceleration of the center of mass? Yes, anyone?
M1 a1 plus m2 a2 by m1 plus m2.
Plus m3 a3, and whole will keep on going it like this, whole divided by m1 plus m2 plus m3 and so on. Okay, so this is the acceleration of the center of mass. Okay, can you people tell me that we had not defined in case of velocity of center of mass, in case of acceleration of center of mass, we are defining it only for the point masses. Yes or no? Previously, when we were defining the center of mass points, x coordinate of center of mass, y coordinate of center of mass, we had considered the different formulas for the point masses as well as for the continuous bodies. But here, in case of velocity of center of mass and acceleration of center of mass, we are only defining it with respect for the point masses. What is the reason behind that? Yes, anyone? Any guesses? Anything?
A continuous body is considered as a point when it moves.
No, not such. Because if we have a big body, we can't treat it for a point mass in any case. If it's moving, so what happened? There's nothing changes. It will keep, it will still have the same size. Okay. So let us see that what is the reason behind that. Okay, let me consider a continuous body and let me mark some dm masses over it. What we used to do in the continuous body, that we used to see it with the small elemental masses. So let us divide it in the small elemental masses. Let us say that this is some small element dm and it consists of this dm. That means if we join, keep on joining this small dm, keep on joining these small dm, we'll get the complete rod. This is actually the mean of the small dm mass. When we used to choose it, we used to choose it in such a way that if we keep on joining that dm mass, we'll get the complete rod. Understood? So if it is like that, so in this case, this will be the dm mass that I had marked over here. This will be the dm mass. Okay, so as it is a dm mass, so it will definitely, like what was happening before, that there was a rod, there was a small dm mass, and it was having some x coordinate with respect to the origin that we had chosen initially. Okay, and we had multiplied that and integrated that. So similar kind of expression we can expect here, that there is a small dm mass, there is a small dm mass at some this time with some velocity v, this time with some velocity v1. Okay, so what is going to happen over here, that when we actually require to multiply this v1 into dm, yes or no, like we are doing over here, that is small m into v. So we are doing the same expression here based on and integrating it and whole divided by the dm mass. Yes or no? Yes or no? Is this clear to all of
Yes.
you?
Yes, sir.
That how I had given the analogy of these two formulas, that previously we were having some point masses m1, m2, and so on. In the continuous body, we are having the small dm mass with some y coordinate over it, and then we are integrating it. The integration, what is integration? Integration is actually the summation, and this is what we are doing over here. Okay, so if we are calculating the velocity of the center of mass, then what should we do? If we want to calculate the velocity of center of mass in the continuous body, so the formula should look somewhat like this, that v1 into dm divided by integration of whole dm. But what is the catch in this? That actually, don't you think that wherever you are marking this small dm, every dm will have the same velocity v1? Okay, so this v1 is actually constant for all the dm. You can take it out of the integration and multiply it with this small dm and integration of whole dm. So what is going to happen over here, that what is this whole dm? This dm and this dm are the same actually, because if we'll integrate this small dm, we'll get a complete mass m, and we can actually get cancelled out. So what is happening here, that if the body, if a complete body, that is the continuous body, is moving some velocity, so its center of mass is also moving with the same velocity. Don't you think that every particle on this rod is moving with the same velocity? So not need to worry about that. The center of mass is not going to change here. Is this clear to all of you?
Yes, sir.
Center of
Yes,
this
sir.
center of mass of this whole rod is going to be in the center always, with whatever the sorry I was talking about the velocity na? So velocity of center of mass is same as the velocity of the individual particle over this rod. Is this clear to all of you?
Yes, sir.
So this is actually what is happening in the continuous body, that in the continuous body we that is why we are not having a separate formula for that particular thing. Okay, is this clear to all of you? And same is true for the acceleration as well. Okay. Yes, Zunara, is this clear to you? Okay, she's typing here. Yes. Okay, no issues if you can't speak. So just keep on listening. And if there is any doubt, just write it in the chat. I'll take it that out. Okay, so in this particular formula, we had seen this particular thing, this acceleration of center of mass in the last class. In the after just after this, what I had done, I had multiplied this denominator on the another side. So what I had written, acceleration of center of mass, multiplication with with this big thing, and what this big thing is. This is the complete mass. So I'm just writing it with the capital M. Okay, is this clear to all of you?
Yes, sir.
Yes, sir.
M2A2 plus M3A3 and so on. What this acceleration of center of mass into M is, this is nothing but called
Force.
F net. That is the net force. And what this small M1A1, M2A2, M3A3 is, M into A is actually called the acceleration. Oh, sorry, the M into A is actually called the force. So these are the individual forces acting over the point masses. So this is F1 plus F2 plus F3 plus F4 and so on. This will keep on going. Okay. And what this is equal to F net. Okay. But we should remember one thing, that net force on any particle is due to two of the things. One is external force plus internal force. Is this clear to all of you? The net force
Yes.
over any body will be summation of these two. That is the external forces acting over it and the internal forces acting over it. But from the second law of Newton's second law of motion, which we had not actually covered here, but I need to take that reference. But that's a very small thing, so not need to worry about that. So from let me write it over here. From Newton's second law, what we can see that F net is actually equal to F external. Net force on any body is only because of external forces acting over it. So from this, what we can write here, that F internal is equals to 0. Is this clear to all of you?
Yes, sir.
Yes, sir.
That means internal forces cannot change the center of mass of a system. Okay, so we can write here that center of mass is affected by the external forces only. Okay, center of mass is affected by the external forces only. And what the second point I had said, that there is no effect of internal forces on center of mass of the system. Is this clear to all of you?
Yes, sir.
That means the internal forces cannot never ever change, will be able to change the center, will never be able to change the center of mass of a particular system. Is this clear to all of you? Yes or no?
Yes, sir.
Yes, sir.
Yes, there is one very famous example of regarding this particular thing. So I'll just tell you over here, and based over this, I'll get a numerical to you in the assignment question. Okay. See, what actually happens is that let us say that this is a let us say that this is a bomb. Okay, and we are throwing it in this particular direction. So don't you think that this is, if it is being thrown at some angle theta, so it will follow a parabolic path and it will move trajectory somewhat like this. Yes or no? It will move
Yes.
somewhat like this. Okay, it will move somewhat like this. It will do the actually projectile motion. You must have listened about this word in your school. Okay, this is also a concept of previous previous chapters, but as we had not completed this, so not need to worry about that actually, because these are some of the small portions which we are taking the reference here, and not related to this chapter in a very great detail. Okay, now what is happening over here, that if this was a bomb, so it need to explode somewhere. So let us say at any point, at any time of point, it explodes. Let us say, let us choose that instant that it explodes here. What happens? It explodes here. If it explodes here, so what is going to happen? That it will basically get divided in number of particles. Yes or no? In our physics term, what we'll say, that it will basically get divided into several number of particles. Yes or no? Yes or no?
Yes, sir.
Okay, so if it will get divided into several number of particle, let us assume that we can assume it in any particle, but I want to take some good numbers so that I can give you a better understanding of this concept. Let us say that it gets divided into two particles. Okay, so let us say that it gets divided here into two particles. So if it gets divided into two particles, so what is going to happen? If one of the particle goes ahead and one of the particle goes like, they will go somewhat like this, na, somewhat like this, they will go away from each other. They can't go towards one thing or towards one side. Yes or no? So they'll go somewhere away from each other. So if one of the particle follows this path, follows this path and falls somewhere here, let me make it this half particle over here, and just comes here down. The second particle will must have to follow this path and will come at this part, at this point, exactly somewhere here. Why here? The reason behind that, because explosion is a force due to the internal forces. Because of that, the center of mass of the system should not change. The center of mass of the system previously was moving along this path, was moving along this path. If one of the particle goes ahead x distance, so previous particle, the if this was the m by 2 half particle, na, and this was also the m by 2, this was the complete m, the previous particle have to lay down behind just by the same distance x, so that its center of mass should not get disturbed at any point of this particular explosion. Is this clear to you people?
Yes, sir.
At any point, if you see that m by 2 mass is here and m by 2 mass is here, so at any point, if you will find out its center of mass, you will find it over here at the exactly at the center. Is this clear to all of you?
Yes, sir.
Yes,
Yes.
sir.
So this is going to be the whole concept of the center of mass regarding the internal forces and the external forces. Okay.
So, and is this the same for how many other particles it explodes into?
If it is,
If it explodes into like maybe more than two,
hmm, yes, yes.
will it
Okay.
still, the center of mass will still be at the same point?
Yes, exactly. In whatever the number of particle it explodes, doesn't matter. The only thing which matters is that its center of mass should remain exactly, should not get disturbed. It should still follow the same parabolic path. That, have you seen this? That its center of mass is still following this same parabolic path. The masses are not following that. One of the particle is moving ahead. One of the particle is had fallen down before. But its center of mass is always going to follow this highlighted path only. It is not going to change, because the reason behind it, no external force is being applied. The explosion was due to its internal forces, and internal forces never changes the center of mass. Is this clear to all of you?
Yes, sir.
Okay.
Yes, sir.
A better question regarding this can be asked. Let's say that if the bomb was somewhere here, it was just thrown like this and is going somewhere here. Okay. And let's say at any point it explodes. Let's say this time it explodes into two particle m by 3 and 2m by 3. So what is going to happen? That this m by 3 will be somewhere here closer. I mean to say that this m by 3 will be somewhere here, and this 2m by 3 will be somewhere here regarding the closed particle. Okay, regarding the regarding it will have a less distance and it will have a large distance, because center of mass is always located to the larger mass. Yes or no? Have you people realized this till now?
Yes,
That
sir.
center of mass, you always get the point of the center of mass to be located towards uh, the higher mass. Okay, so what is going to happen, that if it was following if see, the particles had get divided here and was following two different paths. That was this is somewhat m by 3 and this is 2m by 3. Again, the concept is same, that the center of mass will remain same here at the center. If it will get divided into the several particle, you already know the that how to calculate the center of mass of the point masses. You can calculate it down using that, but always you will find it out that the center of mass do not changes if no external force is being applied over it. It only changes because of some external force being applied over it. Is this clear to all of you?
Yes, sir.
Okay, I'm not solving the numerical over here. I'll give it to you in the assignment, but the only concept you will always have to use is that the center of mass will remain always at the will not change if only internal forces are being acting over it. Is this clear to all of you? Yes or no?
Yes, sir.
Yes.
Okay. And two more things. Actually, this center of mass is going to end now. So just wrapping it over here. Okay. With some uh, good knowledge to you. This is actually the cone. Can you people see this? That this is a cone. But the only difference is one is hollow and another one is the solid cone. Is this clear to all of you?
Yes, sir.
Yes, sir.
Okay. What you have to do, just join this center with the with its vertex. Okay. So this is actually the right circular cone that I am talking about. So let's say that this complete height is h. What this is? This complete height is h, and this complete height is also h. Okay, so let me make a line over here over the h by 2 over h by 2 at a distance. I'm just making a reference line over here that is dividing this height into two different heights. Okay, so if we are dividing it into two different heights, okay, Aman, tell me that which of the side, or the first side or the second side contains the more mass?
The second side.
Second side contains the more mass. Yes, Zunara, tell me, if we talk about the hollow one, so which of the side will contain the more mass? Sorry, Zunara can't reply right now, but reply it in the chat. Okay, which of the side contains the more mass? First one or the second one? Okay, so okay, this is the hollow one. I want to ask that which part, the hollow ones, in the hollow one cylinder, in the hollow cone only, which of the part, the above part or the lower one part contains the higher mass? Yes, Rasha, tell me. The first half or the second half?
First half?
This is this small one, and this is this bigger one. Don't
But
you think the second one will contain the higher mass? Okay, is this clear
it
to all
is
of you?
hollow?
It is the hollow. I'm not comparing the solid and hollow. I'm not comparing the solid and hollow. I'm comparing these two portions, this above one portion and this lower one portion, in the hollow one only.
Okay, so thank you.
Okay, so I'm not comparing, don't get misconfused over here that I'm comparing the solid and hollow. I'm just comparing the hollow with hollow and the solid with solid. So if the lower portion contains the higher mass, so don't you think that the center of mass will be with some lesser height than h by 2? It will be below h by 2 of this cone. Yes or no? The center of mass will be below. Yes or no?
Yes, sir.
Okay, so for solid, the center of mass is at a height of h by 3 from the downward. Center of mass is at a height of h by 3, somewhere over here. Okay, and for the hollow, the center of mass is at a height of h by 4. Is at a height of h by 4. Is this clear to all of you? This is the point where you can treat the whole mass to be concentrated in this cone. Okay, because this is again something that we can't calculate it very easily. That's why I'm giving you a direct result for it. So remember it. Just remember it. Okay, is this clear to all of you?
Yes, sir.
So okay, so these are some of the points which you should always remember about. Is this clear to all of you?
Yes, sir.
Okay, so these are the two center of masses about the solid and the hollow one. That for the solid cone, the center of mass is at a height of h by 3 from the downward, from the base, and for the hollow one, the center of mass is at a height of h by 4. Is this clear to all of you?
Yes, sir.
Yes. Now write some note points regarding the center of mass. That center of mass is independent of frame of reference. Yes or no?
Yes.
What do I mean from this? That to wherever I'm choosing the origin doesn't matter actually. The only thing which matters is that I'll get the same center of mass. Maybe the coordinates will change, but the position of the center of mass is not going to change. Is this clear to all of you?
Yes, sir.
Okay, the next point is only external forces can affect center of mass. Internal forces can't change the center of mass. Is this clear to all of you?
Yes, sir.
Yes, sir.
Okay. What next we can write here? That if F external is equals to 0, that means that acceleration of center of mass is 0. Yes or no? Because what is F? F is equal to m into a. If F is 0, that means acceleration is 0. Yes or no?
Yes, sir.
That implies that velocity. What is acceleration actually? Acceleration is change in velocity with respect to time. Yes or no? Do we used to write acceleration equals to dv by dt? This is again regarding some previous knowledge, that if acceleration is 0, so what can you say about this v? The differentiation of what is 0? Yes, anyone?
Velocity.
Differentiation of, if I'm writing the d by dx, there is something inside it, and I'm saying that it is 0. So what could be inside this?
Constant.
Yes, it is constant. So what should we say? That whatever is inside it is constant. V equals to constant. It may be zero. I'm not saying that velocity can't be zero here, but what should be we should be sure about that velocity is constant over here. So what should we say? That velocity of center of mass will be constant if external force is zero. Is this clear to all of you?
Yes, sir.
Yes, sir.
It is the important point over here that external force is zero. That implies acceleration of the center of mass will be zero. And acceleration of center of mass is zero. That implies that velocity of center of mass is constant, not zero. Okay, it may be zero, or we should write that it velocity of center of mass may be zero, but it will be zero. We can't be assured about that particular thing. Is this clear to all of you?
Yes, sir.
Yes, sir.
Okay. Third thing, that is center of mass do not depend total mass of the system. It depends on the distribution of the mass. Have we done that particular one problem that in which we were having the shape somewhat like this, and first of all we had assigned the mass to all the three blocks and had then solved the problem and had got some center of mass. Then we had assigned some 2m masses to them and then had solved the problem and still got the same answer. Yes or no? Have you people seen that?
Yes, sir.
Okay, so remember that the total mass of the system do not affect the center of mass. How that particular mass is being distributed over the system, that is being affected by center of mass. That affects the center of mass. Is this clear to all of you?
Yes, sir.
Okay, this is something that you should remember about. Okay, one more important thing, that is mass may or may not be presented at center of mass. Okay. Can you people, okay, Aman, give me an example of this particular last line, that mass may or may not be present at center of mass. It is not necessary that mass should be present at center of mass. How can I say so?
So an example is a ring.
Yes, example is a ring. Okay, in a ring, what we used to see, that mass is distributed over the boundary, and we got the center of mass at the center. So we are not having the center of mass over any mass. It is present somewhere where there was no actually mass present in the system. Is this clear to all of you?
Yes, sir.
Okay. This is something that we will. This was actually a part of this particular chapter that we had completed till now. Now we are moving on to another thing, that is moment of inertia. Okay. So moment of inertia. First of all, till now what we had seen the center of mass, and center of mass, we had actually got that particular thing and we had completed that particular part of this chapter, that now we are able to calculate the center of mass, regarding any parameter of the center of mass. Like we can calculate the velocity of center of mass, we can calculate the acceleration of center of mass, we can calculate the position of center of mass. That was being completed till now. Now we are moving on to another part of this particular chapter, that is we are going to calculate the moment of inertia. So what is actually inertia? First of all, it is being donated with a capital letter I. Okay, so just write it over here that we used to donate it with a capital letter I. So what is actually, first of all, inertia? So inertia is actually that is something to resist the motion. If we are resisting, the ability of us to resist in anything is called actually the inertia. Okay, that is actually all about the first law of Newton's first law. So now, right now, we are seeing the moment of inertia. That what is the moment of inertia? In the moment of inertia, we actually mean that what is the ability of that particular body to resist its circular motion, to tendency to hold its circular motion. So, okay, so this that is actually the analogy of this particular moment of inertia, that what do we actually mean from it. Okay, but what is more important over here, I'm not writing the definition over here. I'll just keep you in written. Just ask the notes by the team, you will get it in written, because I don't want to waste the time over here, because I'll keep on writing that, so that doesn't mean anything. Okay, so let us see calculation of moment of inertia. Till now, like as we were doing the calculation of center of mass, now we'll do the calculation of now we'll do calculation of moment of inertia. That how we are going to calculate the moment of inertia. Okay, so how you have to calculate it? See, I'm just giving you a very basic thing for this. Just apply this analogy everywhere. First of all, the object, you have to treat that particular object to be rotating about a particular axis. So whenever somebody will ask you to calculate the moment of inertia, he will itself provide you the axis of rotation, about which axis you want to calculate that moment of inertia. Is this clear to all of you? That whenever you need to calculate the moment of inertia, if somebody comes and says you that calculate the moment of inertia of this particular body, so immediately ask to him that about which axis. Is this clear to you?
Yes, sir.
Yes, sir.
So let's say that I had provided you this point mass. Still, the same thing is going to be followed over here. First of all, will do the calculation with the point masses. Later on, we'll switch to the what we say, that the continuous bodies. Okay, because the point masses are easy to understand. So first of all, we'll understand from that particular thing, and then we'll move on to the continuous bodies. So let's say that there is a small, let us consider a small mass m only, one body, 1 point mass we are calculating. So let us say that there is a small m mass, and we want to calculate the moment of inertia. So as I had told you, immediately you will ask the second question to me, sir, about which axis? So I'll say, let's say about this axis. So what you have to do, that how you need to calculate this, calculate the perpendicular distance from that axis to the mass. What will be that distance? That will be somewhere this. Okay, this will be the perpendicular distance from that axis to the mass. And let's say that this is the r. Let's say that this is the distance, that is the r. So you need to define the moment of inertia of this body to be m into r square. M into r square. Is this clear to all of you?
Yes, sir.
This is how you need to calculate the moment of inertia of anything. This is the same thing that I'll always follow to calculate the moment of inertia. That first of all, I'll locate the mass, then I'll ask that about which axis the moment of inertia is required. So he'll provide me that axis. After that, I'll calculate the perpendicular distance. I'll just multiply it in this way, the square of that distance with the mass, and I'll get the moment of inertia. So more explicitly, I should write it like I equals to mass into perpendicular distance from axis to the square. Is this clear to all of you?
Yes, sir.
This is something that is going to be done anytime. Is this okay to all of you?
Yes, sir.
Let's say
Yes.
that there are several particles. let's say these are the points. There are several particles. Okay, let us mark them M1, M2, M3. These are those particles. And let us say I ask you to calculate the moment of inertia of this particular system. So again, you will ask the same question to me that, sir, about which axis? So I'll say about, let's say, this axis. So now you will calculate the perpendicular distances from. Okay, so let's say this is somewhat inside point. So imagine it in the 3D figure. This M3 is somewhat embedded in our screen. Okay, this is somewhat inside, away from us. So that's why it is looking like this. So let me give them R1, R2, R3. Then what will be the moment of inertia here? I equals to, yes, anyone?
M1 R1 square
Square
plus
plus,
M2 R2 square plus M3 R3 square
yes.
by
Okay.
M1.
No, not this. Not
Oh,
this one. Okay, what you need to do, if I am asking the moment of inertia of anything, you just need to multiply that mass with the square of that distance with the axis, perpendicular distance. So we are doing this m1 into r1 square plus m2 into r2 square plus m3 into r3 square. Is this clear to all of you?
Yes, sir.
Okay, so this is the formula, and if it goes for the n masses, just continue it till the m mass. Okay, is this okay?
Yes, sir.
Okay. What is it is first of all, write it over here. Let write the first point. It is a scalar quantity. It is a scalar quantity. The second point. Okay. Okay, Aman, tell me that what will be the SI unit of this? How to calculate the SI unit of this particular moment of inertia? Okay, tell me what is the SI unit of mass? Yes, Aman.
Mass is kg.
Kg. Okay. Yes, Rasha, tell me that what is the SI unit of radius?
Meter.
Meter. Okay, so what will be the SI unit of moment of inertia, that is I? SI unit is
Kilogram
kg
meter square.
meter square. Yes or no? Because we are multiplying the mass and the meter square. So just place it in this way and you will get the SI unit of to be this kg meter square. Is this okay to all of you?
Yes, sir.
yes, sir.
Okay, so this is something that you must know about. Okay, let us do a question over here. Let's say that there is a square like this, and is, let's say, each side is located by A, and let's say that I place the M mass over here at the corners. This is the M mass, this is the M mass, this is also M, and this is also M. Okay, calculate the moment of inertia here, everyone.
So what about the axis?
Yes, exactly. Nobody was had asked me. I'd always said you na that whenever somebody asks you about the moment of inertia to calculate, first of all you have to know about the masses and the axis also. I'd not given the axis over here because moment of inertia depends over the axis. Okay, we'll see here in this question. Okay, let's say about a axis, about a axis, calculate moment of inertia about axis passing through center. Passing through center of a square. Okay, so just remember about these things, that whenever somebody asks you about to calculate the moment of inertia, first of all, you should know about that, about which axis do we need that. Okay, you just do it and then let me know. Yes, did anybody sorry, first of all, okay, let me copy this figure. Okay, I'm just removing these A from here. Okay, so do we need this diagonal length here? Yes or no, anyone? Yes or no?
So why are we taking the diagonal?
Our axis is passing through the center, that is from here,
Yeah.
from the center of a square. So what is actually required here? That we want to calculate this distance from each masses. Do we need these four distances? Yes or no?
Yes, sir.
We need the what is how we are calculating the center of mass always. We are calculating, sorry, how we are calculating the moment of inertia of our system? Always by having these distances from the axis. Yes or no? We
Yes, sir.
want these
Yes.
distances. So let us find this out. What will be this whole distance? What will be this whole distance? Let me mark it as ABC. Okay. If this is the triangle ABC, if this is the point A, this is the point B, and this is the point C, this is 90 degree, this is A, this is A. So what is this BC distance? Yes,
A
anyone?
root 2.
Yes, that is root 2 times of A. Okay, how did we got this? Just by applying the Pythagoras theorem. AB whole square and AC square, AB square plus AC square is equals to BC square. That is the square of the individual sides. If we sum them up, we get it equal to the hypotenuse whole square. So what is this AB square? That is A square. What is this AC square? That is same as A square. What is BC square? That we don't know about. Let it be like this. What will be this? 2A square equals to BC square. Now under root shift the square to the another side. We'll get it as root 2A. That will be BC. Yes or no?
Yes, sir.
Yes, sir.
Okay, so this will be root 2A. So this whole length is root 2A. What will be this length? We want actually, we are interested in this particular length. Yes or no? Yes, anyone?
A by
Yes,
root
anyone?
2.
Yes, that will be A by root 2. Okay, how we got to that particular thing? That this whole length is root 2A. So let me mark this as BO. So what is BO? BO is BC by 2. Yes or no? And what is this BC actually? BC was root 2A whole divided by 2. So it is nothing but A by root 2 is the BO length. Yes or no?
Yes,
Yes.
sir.
So that will be A by root 2. And what is this CO length? That is again A by root 2. The same as before one. Yes or no?
Yes, sir.
That is also A by root 2. And this is also A by root 2. This is also A by root 2. All the distances are A by root 2 only. Okay. Now calculate the center of mass over here. Oh, sorry. I'm still stuck over there. Okay. Now calculate the moment of inertia about this axis passing through O will be m into A by root 2 whole square plus m into A by root 2 whole square plus m into A by root 2 whole square to A by root 2 whole square. Just sum them up and tell me that what will be the final answer over here.
Two MA square.
That is m A square by 2. This will be the 1 and we are having the 4 of this. So it will be 2 times of m A square. Is this clear to all of you?
Yes, sir.
Okay,
Yes.
so this is how we are calculating the moment of inertia over here. Okay, so Acha, tell me that is there any another method to calculate these distances other than using this Pythagoras theorem? Have anybody applied that? Yes, anyone? Nobody? Have everybody were following this particular method only? Nobody was
So with
in.
trigonometry.
Yes, with some trigonometry. What is that? That if we are having the triangles like that, because I prefer this approach of trigonometry because this is something that will be useful everywhere. This Pythagoras theorem will not help you uh, in a much better way. Okay, so this is angle actually that is 45 degree. Okay, and this is actually angle that is 45 degree. Okay, so this is something, and this is the length A, this is the length A, this is 90 degree. So what will be this particular length? Let me name it as L. If you apply the cos 45 here, how can you write it like base upon hypotenuse? This will be the base and this will be the hypotenuse. Yes or no?
Yes.
So that will be A by L, and this cos 45 will is nothing but A 1 by root 2. That is A by L, and L will be nothing but root 2A. L will be nothing but root 2A. So this is how you can calculate the length. And even if you would have tried, you can calculate this direct distance as well. How so? Just draw this triangle that is BAO. If you will draw this triangle that is BAO, you will get this. I'm talking about this triangle. If you will draw this triangle, so it will be B, A, and O. And as you can see that this is the square, so this complete angle is 90, and this is half of it, that is the 45 one. Okay, and if this length is A, so don't you think that this is the side in front of this angle? So it will be A sine 45, and this length will be A cos 45. And if we'll replace the values of sine 45, cos 45, you'll directly get A by root 2 and A by root 2. Yes or no?
Yes, sir.
Yes, sir.
This is these are the diagonals which are at 90 degree. That's why I was able to apply these things over here. Okay, this is something at 90 degree. So that's why we can actually get it directly as well. Okay, now let us have the second part in this. This was the first part. Let us have the second part in this about axis passing through one of the mass. That means you have to take that axis is passing through one of the mass. That is, let's say from this one. Let's say from this one. The axis is passing through A. Then you need to calculate this, the center of mass of this particular, sorry, center of mass still, moment of inertia of this particular system. Okay. Now calculate it. Try to calculate it here. Yes, this time the three distances which you require is one is two of them are becoming the side of the square. Yes or no?
Yes, sir.
Yes, sir.
And one of them is becoming the diagonal of the square. Yes or no?
Yes, sir.
Yes, sir.
So you already know about all these three distances. Yes or no?
Yes.
Yes, sir.
Just apply the formula and get the center of mass for here. Sorry, again, moment of inertia.
Sir, I'm getting 4 MA squared.
You're getting 4 ma square. Okay, I
I'm
think you
also
are getting the
square.
you people are getting the right question or right answer over here. Okay, so let us do it. The second part here. Okay, so what is going to happen that this time this our axis is going to pass through this mass. Okay, we are assuming this mass. You can take any mass, you'll get the same answer. Okay, so Aman, tell me that what is this distance actually equal to?
Sir, what?
What is this distance equal to?
Uh, root 2 by A.
What is the side of this square?
Oh, A.
That is the A. So you'll get
Yeah.
this A. Definitely you are not looking the lecture now. What is this distance? Yes, Aman.
Oh, this is also A.
This is also A. What is this distance?
That is root 1 by root 2A.
I had marked over here. What is this distance BC length?
Root root 2A. Root 2A.
So don't you think that both the diagonals are equal? So this A and this, let's say mark it as D. So this AD length will also be the same one. Yes or no?
Yes.
So that will be root 2 A. Now apply the formula for moment of inertia. What is the formula for that? Yes, Aman.
Uh, Sir, I should say moment of inertia formula.
let's say, yes, let's say that we are talking about this mass. So we'll see this mass. What is the distance of this mass from the axis? What is the distance of this mass from this axis?
Sir,
Don't you think that this mass is lying over the axis, so its distance will be 0? Yes or no?
yeah.
And if we talk about this mass, then what should I do? M into the square of what?
Square of A.
Yes, for this mass, M into,
Which one?
yes, for this mass,
This one, M into also A square.
A square. For this third one,
Uh,
M into this time, what is the distance of the axis? That this is the axis, what is this
root 2
distance?
A square.
That is root 2A square. So that will be root 2A whole square. Now just open these up and you will get MA square plus MA square plus root 2 will, if we will take it out of the square, it will get 2. So that will be 2MA square. And if we sum these up, we'll get 4MA square. Yes or no?
Yes,
Yes,
sir.
sir.
So this is the moment of inertia of the system. So can you see that previously we had got 2MA square and this time we are getting 4MA square. Is this clear to all of you?
Yes, sir.
Yes, sir.
So this is actually that how we are calculating the moment of inertia. And what do we mean from the moment of inertia? That if this particular body starts rotating, we require a larger resisting forces to stop them. Higher the moment of inertia, it will higher resist in its motion. For example, for spinning them also we require a larger force. And for to stop them also we require a larger force. Okay, so ultimately moment of inertia gives us actually the estimation of that how much it is going to resist if we want to change in its motion, if we want a change in its circular motion actually. Okay, is this clear to all of you?
Yes, sir.
Okay, now let us move on to the moment of inertia of continuous bodies. Okay, so let's say that this time, first of all, let's start with a rod. Let's start with a rod. That we have a rod like this, and we want to calculate the moment of inertia. Okay, so now the question arises. What the second question is going to arise over here? Yes, Aman, tell me. If this is the mass M and this is the length L, if I ask you to calculate the moment of inertia of this system, so what will you ask the second question to me?
For the radius.
About which axis? Yes or
About,
no?
yeah.
About which axis you are going to you want the moment of inertia to be calculated. Okay, so uh, let us do it. Let us do it. Let us calculate it. Okay, so let's start with one of the side. Let's say that we are calculating the moment of inertia about this axis. Okay, is this clear to all of you? We want to calculate the moment of inertia about this axis. Okay, so let's say that okay, see, I am always saying it that if it will rotate, it will rotate. That doesn't mean that for to have the moment of inertia, the object need to rotate. No. If it is in a stationary motion, sorry, if it is in a stationary position, then also it can acquire some moment of inertia. It is only about the estimation that how much it will resist if we want some change in its motion. Is this clear to all of you? Change in its rotatory motion actually. Okay, so let's say that this body is somewhat rotating about this axis. You want to calculate the moment of inertia. So what is the actually the formula for the moment of inertia till now we know about? What is that? Yes, anyone?
M1 R1 the whole square. M1
M1
R1
R1
square.
whole square. Okay, so this is the moment of inertia that we had seen. But the problem is that this particular moment of inertia is for the what it is for? It is for the point masses. Yes or no? As this is a continuous body, as this is a continuous body, so what can we do? We can actually uh, can we do something that we can mark a point mass over here, that is the dm mass, and can calculate this r distance from the axis and can multiply that square and can get some expression? Yes or no? Yes
Yes.
or no? So moment of inertia will be, let me mark a dm mass over here. Why I'm marking dm mass? Because this is the continuous body. If I'll mark this dm mass and then I'll integrate it so that it will be get will get a continuous body, a whole complete length of the this particular, that is the rod. Okay, so let me mark the dm over here. Okay, with this dm, what additional information I require? The distance of this from the axis. Yes or no? Yes or no?
Yes, sir.
Yes, sir.
Okay, so let's say that at a distance of r, I am marking a elemental mass that is having uh, some distance, that is, let's say it is dr. Some small length will be covered in this dm mass, so let's say it is dr. So ultimately dm into what I can say, r square. Yes or no? This will be the moment of inertia and I need to integrate it. Yes or no? This can is this formula make sense?
Yes, sir.
Okay, that we had actually pointed out a dm mass which is at a distance of r, having some, as it is a small mass, so it is having some small length, that is the dr over there, and we are having this I. Is this clear to all of you?
Yes, sir.
Now the again same problem which had arrived over there, that while we integrate it, what is going to what we external thing that we want this dm mass to be written in terms of r. Yes or no? Dr actually. Okay, so how do we use to write the dm mass? Can anybody tell me that how we had how we actually had written that earlierly when we were doing the center of mass?
M by L.
Yes, what it is?
M by R squared.
M by r square. This,
We
see,
wrote it as M by
don't
L.
m by l, and then see, don't turn out the
dx.
pages. Okay, don't turn the pages. Write it over here only. Write it over here only. What is this m mass and complete length is l? Yes or no?
Yes, sir.
So have I told you that this complete l length corresponds to m mass? Yes or no?
Yes, sir.
You want to calculate the mass of this dr length. Yes or no?
Yes, sir.
So what is the mass of the one unit? That is m by l.
M.
Okay, just assume it like that. Instead of L corresponds to M, you are saying that L into 1 corresponds to M. That is, L into 1 length is somewhat there, and then it corresponds to M. And if you want to calculate about the one unit, so you need to divide it with the L because it's in multiplication here. On the another side, it will go into division. So assume it like this. Okay, so it is L length corresponds to M mass. So 1 unit length will corresponds to M by L. Yes or no?
Yes,
And
sir.
unit length will corresponds to m by l into dr. Yes or no? Yes or no?
Yes, sir.
And don't you think that this dr length mass is nothing but actually our dm? This is something. This is this small dm that we want. Yes or no? This is the unitary method that how I had used over here. Is this clear to all of you?
Yes, sir.
Okay. So replace this dm mass over there. That is I equals to m by l into dr, and Actually, let me write the r square over here, then dr over here. Okay, let me do it in your way only. You people have must wrote it like this: m by l into dr into r square. Okay, so first of all, you will do it like this, and then in the next step, you people will write it like m by l into dr square into dr. Yes or no? Now tell me that from which point to which point you actually need to integrate it. What is the r going to vary here?
L.
From 0 to L. Okay, so when you are integrating it, you have to place the limit over this R. Okay, so this limit is going from 0 to L length. So it will go from 0 to L like this. Okay, then calculate the I, m by L into R square dr. Yes, what will be the integration of R square dr?
0.
R square dr. What is the integration of x raised to the power n dx? Yes, Aman, tell me. What is this integration actually equal to?
Uh, x n raised to n plus 1
Yes, divided by
by n plus 1.
n plus 1. Okay, so this is the integration one that we use to increase the power by 1 and divide it by the same power. Okay, so this is something that is required over here. So let us do it. That is r cube by 3. Yes or no? Do everybody agree with me over this?
Yes, sir.
Okay, then place the limit from 0 to n. Just place the limits in it and then calculate it, integrate it, and then calculate the answer. Yes, everyone calculate it and then let me know.
ML squared by 3.
Yes. Okay. Did everybody got the answer? Same answer?
Is it ml square by 3?
Yes, definitely. So that is m by L into, if we'll place the upper limits inside it, we'll get L cube by 3 minus of, if we'll place the 0 in it, we'll get 0 by 3. Okay, and 0 by 3 is nothing but 0. That will be m by L into L cube by 3, and that will be, if we'll cancel out the things, that is L, and 3 will be get reduced by the 1, that will become L square, and the answer will be ml square by 3. Is this clear to all of you?
Yes, sir.
Can you people still see that it is still having the unit kg into meter square? So actually you can get the, if you want the SI unit, you can get it from any formula, either by mr square or like this ml square by 3 also. Okay, is this clear to everyone? M is having the unit kg and L is having the unit meter. So ultimately the unit will be ml square by 3. Okay, is this all clear to everyone?
Yes, sir.
Okay, so this is the moment of inertia about this particular axis. So what should we write here? That moment of inertia of a rod about its one of the end. Okay, about its axis, about axis, axis passing through its one of the end, passing the end. Okay, so this is the, that is the moment of inertia that we got over here. Let us calculate the same moment of inertia of the same rod having the mass m and length L. Okay, this time it is still having the same mass length L, but this time what is happening? That the axis is at its center. Okay, axis is passing through its center. Okay, so if it is passing through its center, then what will be the moment of inertia? Yes, okay, Aman, tell me that first of all, we want to write the dm mass, yes or no?
Yes, sir.
So let's say that we are having this dm mass, which is of length dr. Okay, it is having a distance of r. How to write this dm mass? Yes, Aman, tell me this time. Don't remember the things. Don't remember the things. Follow the complete derivation. Okay, that will help you, because if you'll remember the derivation, you can apply it everywhere. Okay, so Aman, tell me how to do so. What to do? That L length corresponds to, yes, anyone, L length corresponds to
Half
M
of
mass.
m mass. Then 1 unit length corresponds to
m by L.
M by L.
m by L, and then dr length corresponds to
M by L into dr.
into dr. And what is this? This is actually equal to dm mass. Okay, and this is something that we'll get. Then the moment of inertia will be nothing but small dm mass into r square that we had seen, that we are applying till now. So that will be this. And now what next to do? To apply the to replace this dm mass over here, that will be m by L r square. This time I'm writing it properly. Okay, this will be this, and m by L into integration of r square dr from, yes, what will be the limit this time?
0 to half of L.
0 to half of L. That means you are integrating it from this side to this side. Yes or no?
Yeah.
Yes, sir.
But you need to integrate it from this side to this side. Yes or no? You need to integrate it from one of its end to the another end.
Uh, so minus L by 2 to L by 2.
Yes, exactly. The limit will be minus of L by 2 to plus of L by 2. Okay, calculate it, everyone. And tell me the answer, that what do you get?
Two m L square by 24.
2m L square by 24. So it will get reduced to ml square by 12. Yes or no?
Oh, yes, sir.
Yes.
That will be m by L. And if we'll integrate this r square, we'll get r cube by 3. Yes or no?
Yes, sir.
From the limit minus L by 2 to plus L by 2. So can I take 3 out of it? Because this is unnecessary, making the calculation tedious. So m by 3L into r cube, going limits from minus of L by 2 to plus of L by 2. Just place the limit inside it. You will get it as m by 3L into L cube by 8 minus of my okay, let me write it properly, otherwise you people will get confused. This minus of L by 2 whole cube. Yes, till now, have I written everything exactly correctly? Yes or no?
Yes, sir.
Yes, sir.
Then what to do next? M by 3L into the first one will evaluate as L cube by 8, L cube by 8 minus of, this will be minus of L cube by 8. Yes or no? Yes or no?
Yes,
Yes,
sir.
sir.
If we'll cube the negative number, we'll get a ultimately overall negative number. So that will be M by 3L, and inside it L cube by 8, and this minus minus will get added up and will get L cube by 8. Okay, and that will be M by 3L into 2L cube by 8. So if you will just cancel out the things, you will get 2ml cube by 8 threes are 24L. And now let's start the cancellations. 2, this will get square, and 2, 1, and 2, 12. So ultimately you will get the answer to be ml square by 12. Yes or no? Yes
Yes,
or
sir.
no? Moment of
Yes,
inertia
sir.
of a rod passing through its center. Okay, we had seen that we are getting the different moment of inertia on uh, uh, getting on taking choosing the different axis actually. Okay, so this can say the same question can be asked to you for several other things as well. Okay, let me say that suppose if the rod was here, and what somebody says that this is the rod, and this time you need to calculate the moment of inertia, let's say about a random axis, not so random. Let's just give some distances, that this distance is L by 3. And if this whole length mass M at length L, so what is this length actually? Yes, what is this length? What is this length? L minus L by 3? Yes or no?